Hi there, Pan. Good afternoon.
Hi, good afternoon.
Okay. So
Yeah,
you had done till yesterday's class. That is, we had done, I think, up to the model.
yeah. The modeling part, I reached till the modeling part.
Yeah. So do you have any doubts, like any doubts in the modeling part?
No, not yet. It was fine, I guess.
Okay. Okay. Basically, in the modeling part, people have problems in like the member intersection part. If you don't do it properly, then you have the problem of member intersection and member
Yeah.
collision. So the way which I have shown, if you do it way,
Hmm.
don't have
Yeah.
not have that problem. And another thing, before the modeling part, people have problems in your like they create the grids and it doesn't display in the Tekla structural design properly. That also
Yeah.
follow my procedure and follow my checking procedure as well. That also shouldn't
Okay.
be a problem. Okay.
Okay. Yeah.
But in more upcoming projects also, if you have any problem, then also you can ask.
Oh,
Okay.
yeah. Right.
we'll,
Right.
we'll continue from where we had left, so
Yeah.
we'll pick up that particular file and then we'll work on it. So I guess this is our last class was on first
Yeah.
yeah. Like, are you working right now, like did you find any offers for currently in Canada?
In Ireland, but not yet. I've been applying because now also Christmas started, no? Christmas
Okay.
and New Year.
Okay.
So that much of recruitment won't happen in the end of this year
Okay. Okay.
because they will be in the Christmas mood and all.
Mm-hmm. Like they what kind of software requirement they have, like if you learn Tekla Structural Designer and like what.
So they have asked mainly about ToCAD, and
Mhm.
then mainly they ask of some companies they ask of Tekla,
Mhm.
some they ask of Revit and robot. So
What is a Revit you can learn Revit, like they ask for the detailing part in Revit.
Revit, the detailing part also, because Revit
Detailing
gives us
part.
detailing part also,
Yeah, detailing part and or the architectural part, which one?
and the detailing part.
The detailing part of Revit. Okay, okay.
Yes,
Yeah, yeah.
Revit structures,
Revit structures, yeah.
not the Revit architect,
Mm-hmm.
and also robot structural analysis.
Robot is a like.
It's yeah, it's mainly most asked one.
Yeah, robot is a very good software actually. For
Yeah, but you don't you don't use robot. I
No,
guess.
no, we use Revit structures, but you don't. You have not used. I've not used robot till now. But
But Revit structure can do analysis. Yeah, but they don't rely much on that.
no, no, Revit structures analysis nowhere. It's not reliable. Revit
Yeah, yeah.
used for detailing,
Hmm.
and we are also. I was also looking at what are the next software which I can go. So I was looking into this Prota structure and
Yeah.
then this robot. So
Hmm.
did anyone mention about Prota structure there?
No. Prota structure. There are few companies like in UK and all. Some companies they do mention.
I think it's a Chinese-based company, Protestex. I don't know much about it, but
Yeah.
I have the demo videos which I've seen. That particular just like you are doing, it's similar to the Tekla interface. And
Mm-hmm.
difference is that the detailing also can be done within a single software. Like I am design
Okay.
detailing also can be done within this software only. So that's an advantage. So
Yeah.
it's like kind of
There,
yeah, excited.
there's one more software series, M series or something.
Not
Uh,
Midas. We have a software called Midas.
Midas, no, Midas I know. I mean, there's one more called M series or something. It is
Okay, okay, okay. I haven't heard about
that. Yeah, it is also like many companies are asking about that.
MC.
Yeah, M series or something. Properly, I don't know. Next time I'll tell you what's the name.
Okay, yeah, yeah. You can text me that name.
Yeah, yeah.
robot
It's
I
comparatively, I've seen the software. It's in YouTube and all. I've seen it's
Hmm.
much more easier. Like you can do everything in that one software.
Hmm. Hmm.
I don't know. I forgot the name. I'll let you know in the next class.
Okay, okay. So, like the companies which you are going, are they asking for the Tekla Structural Designer or Tekla Structures? Which one they are asking?
They are asking about Tekla structures.
Mm-hmm.
Yeah. So and yeah, Tekla structure designer and all they don't mention. So
Okay,
you should have knowledge of Tekla structures. That they mention.
okay, they are only telling Tekla Structures
Yeah.
because Tekla Structures is a separate thing. It's like for the detailing field.
Yeah. It's in detailing also. Yeah. Yeah. I know. Yeah. But
This,
analysis, they mention AutoCAD and Tekla structures. So
okay,
analysis part also, I guess, matlab, if you know
okay,
Tekla structure designer also, it's an advantage. That's why.
okay. So they are basically looking for a structural detailer. Like
Yeah, yeah.
they will give you the
Nay,
design.
you should also have knowledge of detailing.
Yeah, yeah. You should also have knowledge of design, but
Hmm.
basically they're looking for the detailing part. Like
Detailing, it's not clearly mentioned detailing, but they also mention that you should also know,
hmm.
you should also have knowledge of that both.
Yeah, yeah.
So that because if they're looking for detailer, they'll mention like a structural detailer,
Hmm.
or clearly they'll mention like that.
Yeah, everything has now become multidimensional. I think they need both.
Yeah,
Need both.
yeah, yeah.
Yeah, they're looking for someone who can do the design as well as the detailing.
Yeah.
That's why they had mentioned AutoCAD. Otherwise, they wouldn't have mentioned AutoCAD.
Yeah, because they're here, there are separate departments for AutoCAD. Like
Mhm.
you have people who are into AutoCAD only. So you have people who are into designing only. You have people who are into detailing only.
Okay.
So there are very few companies who ask all the three. Maybe they want to save the time, save the money. Who knows?
Mhm. Hmm. Okay. Okay. So I guess
Yeah,
after you complete this, then you'll have some knowledge about the design,
yeah,
and then when you understand the design, it will be beneficial for the detailing also.
yeah,
Yeah. Okay. So after you have completed this model up to this, we can apply our loads. So for applying our loads, we will discuss a few basic things about our loads,
yeah.
and we'll proceed forward. These are very, very basic things, so we'll not take much time on that. We'll just
Okay.
brief overview of these things because so we have like two types of loads, as we know, that vertical load,
Yeah,
horizontal loads, and the vertical loads. What are the loads which come under the vertical load? That are the dead load. Dead load, we know that self weight of the members. Now, self
yeah,
weight of the members actually depends upon what it will depend on. It depends on the unit weight of the concrete and the unit weight of steel. So
yeah.
it is calculated in the Tekla Structural Designer automatically. We don't have to
Okay.
calculate the we don't have to calculate the self weight. In some
Okay.
like stat, we have to calculate the self weight. So it's an
Okay.
bonus that we don't have to calculate the self weight here.
Right.
Now next comes your wall load. Wall load we have to calculate, and what are the factors which by using which we can calculate the wall load? They are your wall thickness
Hmm.
and your unit weight of the masonry material which you are using,
Hmm.
the plaster thickness which you are using, and the
Hmm.
wall height. So these
Right.
factors on which the wall load depends on. So I can show you how to calculate the wall load, but I will say I'll share a video with you on how
Okay.
to calculate the wall load. So
Okay.
if you don't get it, then we can discuss. So I want to yeah.
Right.
And the
Okay.
service load, so service load depends on the kind of any kind of materials which are using, like if you're using like a particular kind of tile and it has a particular service load. So these things are mentioned in IS 875 part 1. So
Okay.
if you go as per the Indian codes, so these are the things, and the live loads. So
Hmm.
live loads actually depends on the usage of your floor. IS
Yeah.
875 part 2 has a particular table
Hmm.
in which the usage of all these uh, according as per the usage of the building, the loading has been classified, and in which condition, like you can take 2 kilonewton per square meter square, in which condition you should take 4 kilonewton. So everything is mentioned, so we'll just look into that IS code as well.
Okay.
And next comes our horizontal load. So horizontal loads or the lateral loads. So the two loads which comes under the horizontal loads are the wind load and seismic load. So wind
Okay.
depends on the mainly on the height of the building, and of a building. So you are using the you will be using the uh, your BS codes, right?
Eurocode.
Eurocode. So I think in the Eurocode you don't have the wind load.
No, but in Ireland there's like very strong wind,
Okay. Okay.
so they use wind load, and they also sometimes add snow load because sometimes it snows very rarely.
Mm-hmm.
But
Hmm.
seismic in this zone, in this country, there's not much of earthquake. It's not earthquake prone basically.
Okay.
So I don't think so. They consider seismic, but yeah.
Okay. So they are different. I think in I had in British code there is not much importance of wind. So it
Hmm.
different zones, but the basics should be the same. So the
Yeah.
wind basically depends on the height of the building and the area of the building. The
Yeah.
seismic load, the weight of the building, along with the type of soil, plays a very important factor because seismic means earthquake originates from the ground. So
Yeah.
type of the soil, the weight of
Hmm.
the building, and the area of the building. This depends. This impacts our seismic loads. So
Right.
before assigning our load, so we will just have a like a brief over
Hmm.
the IS code because we need that the self weight, how to calculate the self weight of the wall, the video else,
Yeah.
and remaining things will we need to discuss so that we can get an idea about that.
Okay.
So let's go to the IS 875 part 1, which is
Yeah.
for your dead load. So basically we have these IS 875 series, which was drafted in 1987.
Hmm.
And these IS 875 series are the codes for our loads. 875 part 1 is for our dead load. Part 2 is for your imposed load or live load. Part 3 is for your wind load, which was revised in 2015, by the way.
Okay.
So, and part 4 is for your snow loads. And in India, snow loads is applicable in Jammu Kashmir and in some parts of your like Uttarakhand and Darjeeling. So there are some places in which snow loads is applicable. So how
Hmm.
to calculate that is mentioned there. And part 5, 875 part 5 is for your load combinations.
Hmm.
We have a separate code for earthquake, which was also again revised in 2000, and I think what's the year in which it was revised? 2015, 15, the wind 2016. It was revised in 2016. So we have the IS 1893, which was revised in 2016, which is the code for your seismic load. And
Okay.
we already know the code for RCC and steel, that is IS 456,
456. Yeah.
IS 800 for steel. And
Still.
so there were these particular two codes, and these are the codes for our detailing. So now,
Okay.
so now if we just go into this by a particular IS 875 part 1, let's see what are the things which we can observe in it, and we can also mark those certain points. So first
Okay.
of all, IS 875 part 1 contains the self weight of all the members. Like if you need to prove what is the the self weight, as you can see, these are the types of the loads which are mentioned in the code: part 1, part 2, part 3, part 4, and part 5. So you'll have this here, and this table is very important because in this table you will have the unit weight of all the materials which you want. Like I'll we can show you some important things, like you have the unit weight of river sand
Hmm.
here, and you have like asbestos, cement. I think important. Let's see something important. The bitumen,
Bitumen.
yeah,
Okay.
and then bricks.
Hmm.
As you can see, this is the common burned clay bricks. This is
Yeah.
talking about the red bricks, and it is between 15.7 to 18.85 kilonewton per meter cube.
Hmm.
So this is the unit weight of common burned clay bricks. It varies between it,
Okay.
and we have like
There's concrete blocks.
concrete blocks. We have a separate code for concrete blocks, so in that you'll find the unit weight. But from where you purchase the concrete blocks or the fly ash bricks,
Hmm.
you can ask for their certificate. So in that, the unit weight will be mentioned.
Hmm. Hmm.
You can take it from there. But since red bricks has been used for a long time, so we have the standards for that. So here we have the you have the cement, the your unit weight of precast concrete 23.5, which we
Mm.
can take as 24. You might have taken in while doing numericals. And the unit weight of concrete mortar is 20.04. Unit weight of concrete plaster is also 20.04.
Mm.
And this one we actually take as 24. And we take as reinforced concrete unit weight we take as 25.
25, yeah.
So here also you can find the range. With
Mm.
1% steel, this is the range. With 2% steel, this is the range. With 5% steel, this is the range. So this is the range of the unit weight of concrete. So since it comes under 24.2, so we take 25 in our textbooks. But
Mm.
it is the actual origin is from here. Many few people know that.
Okay.
Yeah. So like this, we can find the unit weight of various materials in the IS 875 part 1.
Okay. Granite and all. Okay.
You have another section for bricks again 18.85. So it's
Mm.
mentioned like masonry if it's common bricks. So this is the unit weight of it.
Mm.
And mortar also again it's mentioned 20.4. So same things have been repeated. So next you'll find for the steel section the nominal weights for the steel sections.
Mm.
Okay, that's all. Like it ends with all the unit weights of all the materials as 875 part 1. So 875 part 2, if you go, so the main important thing which strikes uh,
Loads.
your basically this definition is very interesting. So of the imposed loads which they're given, you
Mm.
can go through that. Basically, I'll tell you the overview. It is telling that the imposed load is basically the loads of all the things, that is all the living things, and also the movable parts like the furniture and
Mm.
movable parts, and except your wind, seismic, snow, and other loads. So it's telling that the load which is caused by the movable parts or caused due to the movable parts or occupancy. Occupancy means us, the dwellings, the dwellers of the building. So
Mm.
occupancy and the movable parts of the building, the loads caused by that are known as the imposed loads.
Mm.
So now this term occupancy is very important because like based on the occupancy, it depends like how many people will be using that particular structure and in what way they'll be using. So
Right.
based on the occupancy, they have classified the buildings into 8 categories.
Okay.
So if you want to understand these categories better, you can just simply take one or two examples of all the categories like assembly buildings. Please, you
Mm.
can if you can read one or two examples of the assembly buildings from here.
Mm-hmm.
We have this dance hall, starting with worship.
Right. Right. PS study. Yeah. Okay.
Yeah, so these dance halls, worship, club rooms. So these are the assembly buildings. Business buildings, and in business buildings we have office buildings and as well as your educational buildings. Both are your business buildings. So
Mm.
in business buildings, if in the office building category we have the all the buildings in which the paperwork is done, telegraph, clerical work, administration, all the office buildings and all the educational buildings. These are also the business buildings. And next we have the industrial buildings. So industrial building means your like power plants, factories, mills. So these all are the industrial buildings. And we have the institutional buildings. These institutional buildings include like your courts, jails, prisons, and hospitals. These are all the institutional buildings. Mercantile buildings. In the mercantile buildings we'll have the uh, wholesale, retail, office services, storage services. These comes under mercantile buildings, and residential building will include normal dwelling units as well as apartments. And storage buildings will include all kinds of storage like warehouse and like
Mm.
garages, hangars, everything. And so these, even the airport hangars in which the airplanes are stored, these is also a type of a storage buildings.
Okay.
So
Right.
this is all about the classification of the building.
Mm. Okay.
Now we have this particular table. So this table is very important. This is the table for the imposed loads. Now we have the imposed loads table is given is related to the previous categories of buildings which you have made. Now when we are practically making a building, it might be used for different purposes. Like in the first two floors might have residential purposes. In the top floor, your client may make for a restaurant or a cafe at the terrace. So like that you can do. Like I can tell I will have a party, like a club in my terrace, and the bottom two floor will be used for the residential purposes. So in that particular scenario, as a structural engineer, what we'll do is like we'll put different live loads in different floors. Like we'll put 2 kilonewton per meter square in our ground floor and first floor, and the 4 kilonewton per meter square that is for the commercial in the remaining floors. So how can we do that? We have this table for our guidance. As you can see, dwelling units, in the dwelling units, if you have normal like rooms and all, you can give 2 kilonewton per meter square load. And if you have balconies and staircase, corridors, so all these things where communication is more, so there you can give a live load of 3 kilonewton per meter square.
Mm.
And everything is mentioned like for they can see this. You can see if it is an institutional building, then for the dining rooms you can give 3 kilonewton per meter square live load. So if it's an SMG building, you can like a restaurant, and there you can give a live load of 4 kilonewton per meter square. Considering restaurant and bars, without in that you will give a live load of 4 kilonewton per meter square. If it is bank, so everything is mentioned. So
Mm.
this will guide us in giving the particular live loads to our structure. You can see the boiler rooms also live load
Mm.
given. So these things, this is the main purpose of your IS 875 part 2, that is the load for your vote for your input load. And then after we discussed about the vertical loads, we can assign the vertical loads first, and after that we'll go with the seismic load and the wind load.
Okay.
So let's go to the plinth level. We'll assign our loads for our walls here. So
Okay.
we have the beams. Thin beams are
Mm.
given at all the places in which above which we have walls, both
Yeah.
5-inch walls and both 10-inch walls. So the places which you have 5-inch walls, so we'll provide a dead load, that is the wall load with the in the
Mm.
form of UDL of 5.5 kilonewton per meter. And where we have like 10-inch walls, we provide a wall load of 11 kilonewton per meter. So how to
Mm.
calculate? I'll just send you a video on that.
Okay.
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 I will not uh, waste discussing that.
Mm.
So we'll go to like load, and after you go to load, you can select from below here any type of load. Like if you select dead load, and we'll select full UDL, and after
Okay.
full UDL, we'll take a load of 11 kilonewton per meter. So it's very simple. We'll just click on all the external walls which we have, and we need to make sure like if we press it only once, we don't press it more than once, otherwise it will be assigned twice. We don't want that.
Okay.
So like that, if you find this particular, as you can see, this entire thing will be selected. But if you just observe the plan, I think we have our garage portico here, but
Yeah.
in the plinth level, can we check architectural plan?
Yeah. One. Yeah. Just. to open that. Um, yeah, it's a parking area.
It's a parking area, no?
Yeah.
So the parking, we have the parking area here, like which is the portion of the parking? This one, or I
No,
think
no, no. Yeah, this side. Yeah.
this one only. This is the staircase, eh?
Staircase. No, no. But in the ground floor, the car is kept there in the staircase area for now.
Okay, the car is kept here, na?
Yeah.
We have the car here, so this will be a 10-inch wall here. There will be a 10-inch wall here. There will be a 10-inch wall here because this is the,
Yeah.
and we'll give a 10-inch wall from here to here. So if you have such a condition, we can use the option of UDL, and
Okay.
you can just pick the line in which you want to assign. Single click here and another single click or double click here. So we assign,
Oh.
and
Okay.
similarly we'll assign the load for our remaining parts like 5.5 we want to apply. So first of all, you need to pick your line in which you want to apply that, because we are not applying UDL, we are applying we're not applying full UDL, we're applying UDL. So click here,
Okay.
double click here. After that,
Okay.
full UDL, because all the remaining things will take 5.5 kilonewton per meter.
Yeah.
So we are doing this. So you can also view it from the 3D view, as you can see, and the software is actually very interactive. You can also, like, if you just select on the load, then you can also change the value of it. Like if you can see, you can change to 15. So yeah, you can change it around.
Okay.
It's very interactive, and you can, as you can see, this load is 5.5, so its magnitude is showing less. So, and if you want to rotate the model, you can right click and then you can rotate the model. So we'll do it back to 2D. So
Okay.
we have applied the load. You can also see in the structure 3D view
Hmm.
dead loads we have applied. So
Okay.
similarly, let's just apply our loads in the next level,
Hmm.
and this will be our structure 1, and we are applying
Okay.
the dead loads. So to apply the load, we'll go to loads. Here we'll select the dead load.
Hmm.
Let's go for the full UDL, 11 kilonewton per meter.
We can't just copy the same load on the first floor and then additional add.
No, we can't do that because we have the slabs. So if you copy that, the slabs will disappear. And we also have different beams for that, na? This beam is not there. This beam,
Okay. Okay. Right.
remember.
Right. Right.
So now this is the staircase. So we have to apply it along the staircase one, and this
Hmm.
will be, if it is a 10-inch wall here, so we'll take UDL, and like we'll hover mouse over here, from here to here we'll give 11. Escape, and we're done here,
Hmm.
and we'll take 5. So first of all, we'll take this mouse from here to here and 5.5, and then click here to here. So after that, we will select UDL again, 5.5, from here to here. So all the partial ones you have to do with UDL, and
Okay.
full ones you can do by full UDL. 5.5, 5.5. Okay, so we're done here, and now we'll
Hmm.
apply imposed load. So imposed load, we have a residential building, so we'll apply imposed load of 2 kilonewton per meter square. So for that, very simple. You'll go to level
Okay.
load, and you can apply imposed load of 2 kilonewton per meter square, and you simply just need to click on this, and if you check in the 3D view, the entire load has been applied. So you check in the structure
Okay.
and turn on your imposed load. The imposed load will be applied. You can click on it and change the magnitude of this as well if you want.
Oh, okay.
It's very simple. So now we'll copy these loads to two more levels, that is structure 2 and structure 3.
Right.
Now, after this has been copied, we'll go to construction levels and we'll make them back as unique.
Okay.
After we have made them back as unique, and we can apply the loads on a terrace. So the loads on the terrace will be different because there will be load of the parapet wall. So you're
Hmm.
taking load of the parapet wall is 2.5. So that calculation is also given there. You can check how to calculate this.
Okay.
2.5 kilonewton per meter we are taking from the parapet wall.
Okay.
2.5 also, 2 also we can take. It's like 5.5 is for your 5-inch wall. It's 5-inch wall and height of 3 meters, and the parapet wall is a height of 1 meter,
Hmm.
and it will be, I think we'll take 2.
Okay.
We'll go to the level and we'll go to the top level, that is structure 4, and we'll apply our loads for our staircase first. Staircase
Hmm.
portion will be 10-inch wall.
Hmm.
So we'll go to load, we'll select the dead load from here, we'll select full UDL, we'll select 11, and we'll apply the loads here. And here I will apply the load of the parapet wall to UDL. So that's the technique of providing the UDL. So yeah, so we are done here, and let's go with the impose load also. Impose load, level load, 2 kilonewton per meter square. Loads applied. Check. Now let's move now. In the headroom, we don't need to provide any parapet also. We don't have any impose load also, so we don't need to provide that. So now we have finished providing our dead loads and our live loads.
If on a terrace, if there was a steel structure frame like truss and all, so that additional load will be added along with that.
If in the terrace, if there is a like a steel frame structure,
Yeah, steel like column. Normally, if you see in building for
yeah,
party,
like let's yeah, I got your point. Like take let's take a column,
hmm.
and yeah, we can't model a steel here over it. So but let us try. So
Okay.
I'll go to the base level as our structure 4. Top
Okay.
level, let's take a structure 5. So let's create this particular zone for our party.
Hmm.
1, 2, 3, 4. By the way, you can change the section, so I'm not showing that. You can change the section
Okay.
in the grade. I'm just doing this. You can change the section from here. New value.
Okay.
You have all the sections as per, yeah, as per the codes of the country which you like. You can
Hmm.
change sections also as well. So I'm not just showing this.
Okay.
So we have added the beams, and now let's also like add our in the structure 3D. If you work, I think it will be better, or you can do this as 3D. Here we can work, or we can go to structure 5. Here we can work.
Hmm.
It's better. We'll go to the beams. Let's create some steel beams, and we can create some truss as well if you like to. Like we'll create some truss here, and let's go for a pitched roof, and like start point and end point of the truss, let's define that. Or we can apply, yeah, you give it this type. Okay, we'll go with this one. We'll go along this one. Okay, next. And next, we can define the height of the truss. Let's give it let's 2 meter height, let's give it. Okay,
Okay.
okay, or 1.5 meter, let's give it 1.5
Okay.
meter. Can increase or decrease. We'll go for simple Pratt truss, and we'll
Okay.
division, or 2 divisions will go, or 3 looks good, 3.
Okay.
And then finish this.
Hmm.
Yeah, and then if you go to the 3D view, yeah, actually what happened is like we actually, which we need to redefine the level, because it's coming up to the levels in which we had created. Like if you change the spacing to, let's say, 3 meters, and okay, should that change? Yeah, because it's not having, enough space to like create the characters. That's why it is coming. Like let's say we have one, we taken 1.5, right?
Yeah.
Yeah, so it must be like it with 3 meters, so it must be like, let's say, 5 meters, or let's say if we insert another level. Okay, let's check in the 3D view whether it's coming or not. Yeah, in the 3D view it's visible. Okay, so that's not a problem. So the
Okay. Okay.
bread truss is done, and
Hmm.
after the bread truss is done, we can copy this, like
Hmm.
from here to here along different points. So for copying them also, like we can do it along the grid lines.
Yeah. Oh. Okay.
So you can use the grid lines for copying, or you can also create. You can go to the structure 5. You can go to the top view. So if let's check if we copy this, and the entire thing is copied, or the half the thing. So we need to check that. So we go to edit and we'll copy one and check. Like if you copy here, check in the
Hmm.
view. Okay, the entire thing is coming, so there is not an issue.
Okay.
So we just need to, what you need to do is we need to create some, we'll go to home model, and we'll create some, or not grids, we'll just, let's create some, construction lines. So here, if you measure the length of it, let's say what length we got, 3.2 meters. So
Hmm.
let's give it 1 meter, sorry, 1.5 meter, and, or let's give it 1 meter and then 2 meter. We give it one,
Okay.
so we give it 2 meters. So and like that we can do, and the remaining thing will cover.
Okay.
Okay. So parallel quick, and we'll take a distance of, let's say, 1 meter. One, enter, and there will be like 1 plus 2, that is 3, or like 2.5. It will be here. Okay, let's take 2.2. Let's get 2. Yeah. So we can select the truss. Let's see what has been selected. Yeah, truss, and then we can go to edit option and copy this from here to here to, this one is not taking, we need to, yeah. Like this we can take, and we can go to the structure 3D view. Like, okay, we need to get another one. You take another one, copy from here to here, and then you can model this actually.
Hmm.
Use, go to the model, you can have the option of roof panels, and you can apply the roof panels here. So like this you can validate this. Hope there is not any error. Okay, there should be an error, because there is an error of member intersection and member collision. Analysis error, it doesn't matter, but you can
Okay.
have an error of member collision here.
Oh.
So yeah, like these two beams we need to delete, because
What
now,
did you press for indicating the error?
like,
Collision?
I just clicked on this, like, yeah,
Okay. 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 Okay.
doing that,
Hmm.
and
Hmm. Hmm.
we have to do it again, like
Hmm. Hmm.
we have to assign this again, because it's showing the error of member intersection here. So yeah, we have to do that again, and
Okay.
we don't need columns here. Don't We
Okay.
can't provide columns here also, because below there is no support.
Yeah.
I think that was copied by accident, and now it's okay.
Okay.
So like this we can create, and above this you can also assign the loads. Like we need to assign the load, obviously. We'll go to
Yeah.
loads, and, we'll go to like imposed loads, and we obviously can apply some slab loads, or the area loads will be better. Like let's say we'll give a load of 2 kilonewton per meter square for this and
Mm.
for this. Like that we can provide. Yeah.
And for the load for the truss, which is that own imposed load from the truss and all,
We have applied the loads, self weight of the truss, it will calculate automatically.
little
And,
okay.
yeah. And the imposed loads we have applied, though, that's the load.
Okay, then for the terrace, then the additional load from the steel structure will be carried on to the terrace outer periphery.
Mm-hmm.
So then again we have to increase the load. That means
No, we don't have to increase the load because the self weight will be calculated automatically.
okay,
So we don't have to increase the load.
okay,
Yeah, we can do this.
okay.
But it's a thing like we cannot design this particular. We have modeled this, but we cannot design your particular uh, individual truss in this particular software. We need Tekla text for that, or
Oh,
there is software
okay.
connection designer. Tech
Mm-hmm.
designer. So I haven't purchased that. With
Mm-hmm.
a student version or the trial version of that is also not available. So
Mm-hmm.
if you want that, you have to purchase that. Like if your
Oh,
company has purchased that, so that's very easy. Like we don't.
okay.
I think we have to. There is only a single click in which you can do the design. So
Oh, okay.
design won't be done, but
Hmm.
course will be considered on the structure.
So that means in Tekla TSG you cannot design for truss and all.
No, we cannot design for this.
Only concrete
Only
and
concrete and steel. We can design cold form sections. We can design precast. There is an option of precast also. There is an option of cold form sections also. But for
oh,
that precast and cold form, we need Tekla TEDs. And for the truss and the connections, steel connections, we need
hmm.
Tekla connection designer.
Tekla TEDs. What is like
Tekla
Tekla?
TEDs, Tekla TEDs is used for the calculation of your precast and as well as your cold form sections design, uh,
Hmm.
and also sometimes your slab design also that those parts are done in Tekla TEDs. So it's like
Okay,
manual calculation, but it's like an add-on to Tekla. So
okay.
we have
So Tekla structure is different. Tekla TEDs is different.
yeah, Tekla structures is different. Tekla structures is this one.
Mm-hmm.
Tekla
Oh,
structure,
okay,
yeah.
okay,
Tekla TEDs is different.
okay.
The basic it will give whether this truss is safe or not. We can have that, so we
Hmm.
have that, but
Mm-hmm.
the detailed design we won't get,
Okay.
you know
Right.
but you can if you want to build like like we said, we want a simple truss for party, then we can do it in this software. That's not
Okay. Okay. Right.
okay. So I guess you can try up to this portion, and
Okay.
after that we'll have the next session. Today is we'll try to have the next session on Monday.
Okay.
Okay.
Yeah. Right. And one more thing. My this is going to get expired today. So if you have any
Okay, you need
crack,
to crack. You need to crack it.
yeah, but I don't have any. I tried searching. I found, but it was not working for me.
Okay. Okay, I'll try to get the video for you, particular video and file. I have
O-
a few students who can do that, but no, I'll tell them to make a video so that everyone can use that.
Okay, and from where they have downloaded that cracked version, and all, if I get an
No,
idea, at
I'll
least.
just ask them, but basically they're getting a crack version for 365 days, 364 days.
Okay.
From YouTube somewhere they have got the file, and if possible I'll just tell them to send the crack file with the Google Drive. So
Yeah. That will be better if
mm,
possible.
okay, okay.
Okay. Then if it's possible, like today or I don't know whenever, because
I'll
today is
just
the last
contact
day.
yeah I'll just contact them, and
Okay.
whenever they respond, I'll just get back to you.
Oh, okay. Fine. Thank you.
Okay,
Thank you.
bye.
Okay. Bye.